Hello everyone, I'm Shrinika NS studying in second year B.Tech in GM University in CSC department. We are here to present on the course called Machine Learning and the course code is UE23 CS 2401. We are presenting on the topic titled Linear Regression and Decision Tree for House Price Prediction. I'll be explaining the introduction, dataset description, machine learning models. So let us begin with the introduction. House price prediction is a crucial task in real estate, finance, and urban planning. Accurately predicting housing prices helps buyers, sellers, and investors make informed decisions. In this study, we build regression models to predict house price using linear regression and decision tree regressor. We evaluate these models using mean squared error, that is MSE, and mean absolute error, that is MAE. Now, let us see the dataset description. Punima will be sharing the dataset. This is our dataset of the experiment linear regression and decision tree for house price prediction. Using Boston housing dataset, we have used the dataset called California housing dataset, which is a popular dataset used for regression analysis and machine learning, particularly in predicting housing prices. This dataset contains attributes like area, that is square feet, bedrooms, location, and the target variable price. This dataset also includes attributes such as MED-INC, that is median income of residents in the area, house age, average age of houses in the area, average rooms, that is average number of rooms per house, price, that is the target variable representing the house price. Machine learning models used. We will be using two machine learning models, that is linear regression and a decision tree regressor. Linear regression models the relationship between independent variables, that is features, and the dependent variable, that is house price, using a linear equation. Decision tree regressor. A decision tree regressor splits the dataset into smaller regions and assigns each region a predicted price. It captures nonlinear relationships and is prone to overfitting if not properly tuned. Manual calculation of MSE, that is mean squared error, and MAE, that is mean absolute error. MSE measures the average square difference between actual and predicted values. MAE measures the average absolute difference between actual and predicted value. This was about the introduction. Now we will move to the code explanation. We have used programming language Python for our code, and Swati will be sharing the code. This is our code on the experiment house regression and decision tree for house price prediction, where I'll be explaining the step 1 and the further steps will be explained by my fellow mates. The step 1 is importing required libraries. To execute the code, we need to import some of the libraries. Let us see the libraries. Import numpy as np. Numpy is one of the Python library used for numerical operations. Pandas. Import pandas as pd. Pandas is another type of Python library used for handling data sets in table format. Matplot library dot pyplot as plt, used for plotting graphs to visualize results. Fetch California housing, which loads the California housing dataset, which contains house prices. Train test splits data into training and testing sets. And the next is linear regression, implements linear regression model, and the decision tree regressor implements decision tree regressor model. And the last one is the mean squared error and mean absolute error, which performs evaluation matrices. The further part will be The further part will be continued by Purnima.
Hello everyone, I am Purnima from Data Science branch. Here I am explaining the loading the dataset and selecting relevant feature steps of the coding. First, loading the dataset. Data equals to fetch California housing. This loads the California housing dataset which contains house prices and related features. Next, df is equals to pd dot data frame. We convert the dataset into a pandas data frame for easy manipulation. Next, df price is equals to data dot target. This adds the target column which represents the price of the house. Next, step 3 of the code, selecting relevant features. In this, we choose the three important features. Features is equals to median income of the house owners in the area, average age of house in that area, average number of room per house. The next x is equals to df features. It stores the independent variables like a predictor features. Next, y is equals to df price. It stores the dependent variable like a house prices. The next part of the code will be explained by Shilpa.
I'm Shilpa from the ISC department. I'm going to explain the fourth, fifth, sixth step of the coding. The fourth step is splitting data into training and testing sets. X train comma X test, Y train comma Y test is equal to train test split X comma Y comma test size is equal to 0.2 comma random state is equal to 42. It means this code splits a data set into training 80% and testing 20% sets using train test splits from the x train comma y train. Training data used for the train the model, x test comma y test. Testing data used to evaluate the model. Test size is equal to 0.2. 20% of the data is for testing. Random state is equal to 42. Ensure reproducibility of the split. Linear regression model. Linear regression is equal to linear regression. Linear regression fit x train comma y train. Y predicts is equal to linear regression predicts x test. It means linear regression which creates an instance of the linear regression model. Linear regression fit x train comma y train trains the model using the training data. Y predict linear is equal to linear regression predict x test. It means uses the trained model to predict target values for the test data. This process helps the model to learn a pattern in the training data and then make prediction on unseen data. Next, sixth step. Next step is decision tree regressor model. Decision tree regression is equal to decision tree regression. Decision tree regression fit x train comma y train. Y predicts decision tree is equal to decision tree regression predict x test. This means this step trains the decision tree regressor model and makes a prediction. Decision tree regression is equal to decision tree regression which creates a decision tree model. Next, decision tree regression fit X train comma Y train trains the model using the training data. Y predicts decision tree is equal to decision tree regression predict Y test, which means predicts values for X test using the trained model. This decision tree learns pattern by splitting the data into branches, making it useful for capturing complex relationships. Next, further part will be continued by Swati.
Hello everyone, I am Swati from ISC department. Today I will explain the further part of this code. My part is function to evaluate the models. Define evaluate model y true, y prediction, model name. It defines a function named evaluate model. It takes a 3 input as y true, where y true is the actual value and y prediction where the predicted values. Like example, house price predicted by the model. And next, model name is the model name of it is the name of the model. Example, the linear regression. Next, MSC Mean squared error, y true, y prediction, which measures how far the predicted values are from the actual value. A lower MSE means the better accuracy. MAE, where MA is a mean absolute error. Mean absolute error, y true, y prediction, which shows the average difference between actual and the predicted prices. Like MSC, a lower MA is better. Next, printf model name performance. Print mean squared error MSC, where MSC is 4f. Print f mean absolute error MA is 4f. It means prints the model name and its performance. MSC 4f and MA is 4f format the values to 4 decimal places for better readability. Next step is evaluate both models. Evaluate model y test, y prediction, linear regression. Means it calls evaluate model for the linear regression model. Y test is the actual price and the y prediction linear is the predicted prices from the linear regression model. Next, evaluate model y test, y prediction, DT, decision tree regressor. Calls evaluate model for the decision tree regressor. Y predict the predicted prices from the decision tree model. Third step is visualization, means graph plotting. Plot figure size is equal to 10,5. It's create a new figure for the graph where figure size is 10,5. It sets the width to 10 and the height to 5 for the better visibility. And next, plot scatter, y test, y prediction linear. Label is equal to linear regression alpha 0,5. It means it plots a scatter plot for a linear regression prediction where y test is the actual prices on a x-axis, y prediction linear is the predicted prices on a y-axis, and label linear regression. It labels the points for a clarity. Alpha 0,0.5 is the makes the points semi-transparent for a better visualization. Next, plot scatter, y test, y prediction DT. Label is equal to decision tree regressor alpha 0,5. Color is equal to red. Here color is equal to red makes these points red to differentiate from the linear regression. Plot X label actual prices and plot Y label predicted prices. It means the x-axis is the actual price and y-axis is the predicted prices. Next, plot legend. Adds a legend to show which color represents the which model, and plot title, house prediction actual versus predicted. It gives a title to the graph for the better understanding. Next, plot dot show. It means it displays the graph on the screen. Now I will show the output of our code. Here is the output of our code. Output of the house prediction where linear regression is marked in a blue color and decision tree regression is marked in a red color. Output is scatter plot for accrual versus predicted prices. Now the further part will be continued by Purnima for the conclusion. Thank you.
This is our code explanation. In this decision tree regressor outperformed the linear regression for house price prediction. For future improvements can involve the more complex models like a random forest or a neural networks. This provides a comprehensive analysis of a house price prediction using a machine learning models. Thank you, ma'am, for giving this opportunity. Thank you all.